Hi everybody, welcome to this video where I'm going to show you how to identify types of chemical reactions and also how to predict the products if you're given the reactants in a chemical reaction. What you're going to need for this video is a copy of your types of chemical reactions notes. If you're in the classroom, go get one from the side. And if you're at home, you can find this on Moodle where you can either print it or fill it out on your computer. So if you need to go get those, you'll also need a periodic table. So if you don't have those, pause the video and then come back. Okay, let's go. So first of all, when you're looking at a chemical reaction, you're going to notice some letters. In chemical reactions, we can indicate the state of the compound or the element. So remember, state is solid, liquid, or gas, with a letter in brackets. So either S for solid, L for liquid, G for gas. Some compounds are dissolved in water, and we call this aqueous, or we could call this in solution or in an aqueous solution. So if a compound is dissolved in water, they get the letters AQ for aqueous. Okay, so you're going to see some of those as we go through. I'm not going to ask you to be able to tell me the state of a compound. I will always give it to you. Okay, so for synthesis reactions, this is our first type of reaction. A synthesis reaction is when two or more reactants combine to form a single product. You've probably heard the word synthesis before. Synthesis means things being put together. So in a synthesis reaction, you have, usually it's an element plus an element, and they become a compound. Sometimes it can be an element and a compound, and it becomes a different compound with all of those elements present. But usually it looks like A plus B becomes AB. So for example, you can have sodium and chlorine, and that will become sodium chloride. Another example is rust. So if you have an iron object and it is exposed to oxygen over a long period of time, it can become iron oxide. So the first step is to be able to identify it. So if you see an element and an element becomes a compound, you know that it's a synthesis reaction. The key here is that you have only one product. Okay, that is the key way to identify it. If you want to, this is your aspire to do section, you can get the product of a chemical of a synthesis reaction. You can come up with the compound that's going to be the product. So if you have iron plus oxygen, you're going to look at your periodic table. You're going to find iron. And if I don't tell you the charge, you use the most common one, which is the top one. So in this case, that's going to be iron 3. Okay, so iron. And then we know oxygen's ion charge is 2. So it's going to be Fe2O3. And I know this is a solid, but you won't have to. Okay, and then of course, we never want to leave anything not balanced. So I'm going to list my compounds. I have a 3 and a 2 because oxygen's diatomic, a 1 and a 2. So what am I going to do to balance? I'm going to put a 2 here and a 3 here to balance my O's. And then now I have 4 irons, so I'm going to put a 4 here. There we go, balanced. Okay, another example of this is acid rain. So you could have 2 SO2s as a gas, and then when this is mixed with oxygen in the air, it becomes 2 SO3. So now when you have SO3 in the air and it mixes with water from rain, it becomes H2SO4, which is sulfuric acid, and that can fall to the earth as rain. It's not ideal, but this is given off in, here, SO2 is given off in some pollution. So that's what can cause acid rain. Okay, so that's type 1, synthesis reactions. Type 2 is decomposition reactions. So one compound breaks into 2 or more elements, or it could also break into simpler compounds. So what this usually looks like is you have a compound, AB, breaks down into A plus B. Okay, so again, this is a compound. This could be element-element, or could be element and a simpler compound. But in any case, it has only one reactant. Okay, that's the key part here. There's only one compound on the reactant side of the equation. So for example, this is a reaction called hydrolysis, and it's when you break down water. You can run electricity through liquid water, H2O, and it splits into H2 and O2 gases, so hydrogen and oxygen gases. And now remember, hydrogen or oxygen are diatomic, so you have to write them with that little 2. Okay, let's try one. This is KCl. So you look at it and you say, where are my elements here? So I've got potassium, and I've got chlorine. Potassium usually exists as a solid. Again, you don't need to predict these. And remember, chlorine is diatomic, so it gets a little 2, and it usually exists as a gas. Okay, so now, of course, I have to balance KCl, KCl. I have 2, 1 of everything else. So I'm going to put a 2 here, and that means I have to put a 2 here. There we go. If you keep practicing your balancing equations, you will get that fast at it too. Okay, the last one I'm going to show you in this video are single replacement reactions. So a single element replaces a different element in a compound, producing another element and compound. So what this looks like is there is an element in a compound. This element comes in and bumps one of these out. I kind of think of it as like they're bumping this dance partner out, and now these ones are dancing together, and this one is all by itself. So the important part of this now is that you have to, this one that's by itself, it is important whether it's a metal or a non-metal, because a metal replaces another metal. So in this one, if A is a metal, in here, BX, B must be the metal, right? Because we always write the metal first when it's an ionic compound. So A comes in, kicks B out, and now B's on its own. It's a metal, and we have AX, if X is our non-metal. Okay, so it's important. If it's a non-metal, it has to kick out the non-metal. So here, Y is a non-metal. Out of this AX, this ionic compound, Y is going to come and kick out X. So now X is by itself, and our compound is AY. Okay, so for example, this is a reaction we're actually going to do in a lab where we put aluminum foil in a solution of copper 2 chloride, CuCl2. And what happens is the aluminum will kick out the copper because aluminum is our metal. Copper is our other metal. So aluminum comes in, kicks out copper. So copper is over here by itself, and aluminum steals this chlorine, steals its dance partner, and now they are together as an ionic compound. Hydrogen, remember, can act like a metal. So in this situation, lithium is going to come and kick out hydrogen. So we're going to end up with hydrogen on its own. Okay, and this is a gas. And then lithium is going to join up with oxygen, so it becomes Li2O. This is going to be in solution, AQ. Okay, so here, my lithium is a metal, so it kicks out hydrogen, which is acting kind of like a metal here. And now, of course, we have to balance. I like to write them in the same order. Okay, so we have 1, 2, 1, 2, 1, 2 of these, and 1 oxygen. So, is that right? Yeah. So all I actually have to do here is put a lithium there. Or a 2, sorry, a 2 in front of lithium. Ta-da, balanced. Okay, so same thing with a non-metal. Here you have chlorine on its own. It's going to come and kick out bromine, which is the non-metal. So sodium bromide plus chlorine becomes sodium chloride plus bromine. Okay, let's try it here. There's fluorine in sodium iodide. Iodide is our nonmetal. So fluorine comes in and replaces iodide to become NaF and I. And remember, iodine is diatomic, so it needs a 2. So we have NaF plus I2. And now let's balance. Fluorine, sodium, iodine, fluorine, sodium, iodine. Okay, so I think all we have to do here is put a 2 there, 2, and then that means we'll have to put a 2 here. Done, balanced. Okay, I'm gonna pause here. There are some practice questions for you to try identifying, and then if you want a challenge, you can try predicting the products. And then when you're ready, you can come back and watch part 2.